Alrighty, second lesson on probability. So, you learnt with the multi-stage events in the last lesson with the tree diagrams that when you go along the branches you multiply. So that was like saying and, like find the probability of, I guess it was, what was it, a heads and then another heads, and we multiplied along the branch. So when you see the word and, you're going to multiply. If you see the word or, that's when you add between the branches. And if you see at least one, that's when you're going to use the complementary events, 1 minus the probability of none. And there was an example of that in the last video. You also need to know the difference between with replacement and without replacement, because it'll change the values of the fractions on our tree diagram. So with replacement means when an object is chosen and then put back before the next object is chosen, whereas without replacement means the object is chosen and it's not put back. So that means usually the denominators will all go down by 1 each time as you go along the branches, and you've got to be careful about the numerators as well. Just keeping in mind that every time you've got a branch on a tree diagram, they'll always add up to 1 whole. Some other definitions. Independent events, we talked about that today. 2 events are independent if the outcome of the first does not affect the outcome of the second, such as rolling a die and tossing a coin. They're independent events. Whereas if, just say, you were to choose 2 cards from a deck of cards, then they are called dependent events because the probability will depend on what card was selected first. So this is, I guess you could say, a multi-stage event without replacement. So if you were choosing a card and then keeping it and then choosing another card. Okay, so then the probability of getting those 2 cards will be different to if you were just choosing a card and putting it back in the deck and then choosing another card. Okay, and in probability we're going to assume that all outcomes are equally likely. So we kind of discussed that today with some of those examples with the roulette wheel, rolling the red and black, and also the Super 12 team. I guess though in that case though the outcomes weren't equally likely because we talked about the different abilities of the teams and the coaches and the players and all of that. All right. Find the probability of throwing a total of 6 with 1 throw of 2 dice and then scoring at least 10 with the next throw. So, see that word and? So we're looking for a total of 6 and then at least 10 on the next throw. So the and means we're going to multiply. So the probability of getting a total of 6, so here you can see our two-way table, I guess. We've got all of there's the 6, I guess there's the 6 different numbers across the top which haven't been written in, the 6 numbers down the bottom on the second, along the side of the second dice. And then we've got our 36 outcomes there in the middle. So getting a total of 6 means these ones here. So all of those outcomes is there. So the probability of throwing a total of 6 is 5 out of 36. And then remember we've got and, which means times. Then on the next throw we've got at least 10. So at least 10 means 10, 11 or 12. So where are at least 10? There's a 10, there's a 10, there's a 10, there's 11 and there's 12. So getting at least 10 on the next throw is 1, 2, 3, 4, 5, 6 out of 36. And multiplying those together, and that equals 5 over 216. So that's the probability of getting a total of 6 on the first throw, and then scoring at least 10 with the next throw. Okay, another example. Bag contains 6 yellow marbles and 5 blue marbles. 3 marbles are drawn without replacement. Very important. Find the probability they will be the same colour, and then find the probability of at least one is yellow. So let's draw our tree diagram, and this is kind of like what you would be doing. This is like a HSC question. So we've got 6 yellow and 5 blue. So our branches, our first branch, and we're choosing 3 marbles. So our first marble is either going to be yellow or blue. Our second marble is also going to be either yellow or blue. And likewise, our third marble is going to be yellow or blue. And you can see it's starting to get a bit bunched up here. Right, now we need to put our fractions on our branches. So initially we've got 6 yellow marbles and 5 blue marbles, which means there's 11 marbles altogether. So our denominator is 11. Probability of choosing a yellow is going to be 6 out of 11. Initially on the first draw of the marble, and blue would be then 5 out of 11. You can see those two fractions add up to 1 whole. Now if our first marble is chosen is yellow, that means there is 1 less yellow. There'll be, instead of 6, it's going to be 5. And also the total number of marbles has gone down to 10. There's still going to be the original 5 blue marbles. So this probability of getting a blue is going to be 5 out of 10. You can see we got that by discussing that there was 5 blue initially, and there's still those 5 blue in there. Another way, once you've got that fraction, is you can work out what this second fraction is, because these two fractions add up to 1 whole. So let's use that other method on the to work out the next branches. So if the first marble chosen is a blue, that means there's 1 less blue, so we're going down to 4/10 for the next one, which means yellow must be 6/10, because 4/10 plus 6/10 equals 1 whole. Yeah, let's go along the next branch over here. So if the next one chosen is a yellow, that means instead of 5, there's going to be 4 yellows left out of a total of 9. And you can see that the denominator is going to be 9 for all of these branches, because we've chosen a marble here when there was 11, then we've chosen another marble when there was 10, and then we've chosen another marble. So there's going to be only 9 marbles left to choose from on that third draw. So sometimes it's easier to think about that and just put the denominators in first. Alright, and then once you've got the first fraction, it's easy to work out the second fraction on a set of branches, because it always adds up to 1 whole. So if this one here is 4/9, then the other fraction must be 5/9. Alright, going along the next branches here. We've got 5 blue here. If we choose 1, if blue is successful, which it is, that's what this branch is saying, that means blue is going to go down to 4. And that means there's still the 5 yellow left. Going along the next branch, choosing a yellow here, yellow is going to go down by 1. So if there was 6 yellows there to choose from, that's going to be now 5 yellows, which means this is going to be 4/9. And coming down this branch here, if we chose a blue, and then there was 5 initially, then we drew another blue, there's 4, and then there must be 3 blues left. The probability of getting a blue the last time is going to be 3/9, and then that yellow will have to be 6/9. Okay, let's maybe draw in right in our sample space. Yellow, yellow, yellow. Yellow, yellow, blue. Yellow, blue, yellow. Yellow, blue, blue. Blue, yellow, yellow. Blue, yellow, blue. Blue, blue, yellow, and blue, blue, blue. Wow, that was quite hypnotic. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Cool. We've got all our sample space there. Now let's answer the questions. Find the probability they will be the same colour. Same colour means we've all got yellow, 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 or we've got blue, blue, blue. So the probability of yellow, yellow, yellow is going to be, remember, multiply along the branches. So it's going to be 6/11 times 5/10 times 4/9. And the probability of blue, blue, blue is going to be 5/11 times 4/10 times 3/9. So because we're going to be adding these together, we've got the different branches there, going between the branches we add. So multiply those, and then add your answers together. So let me just see if I can make this smaller. Wow, it's amazing, smaller. Okay, so A is going to be 6/11. So going along the yellow, yellow, yellow branch, 6/11 times 5/10 times 4/9, plus then going along the blue branch, 5/11 times 4/10 times 3/9, and let's put that in the calculator. And that equals 2/11. And then let's work out B. Then find the probability of at least one is yellow. So you can see what yellow, 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 yellow. So remember from complementary events last time, the probability of at least one yellow is equal to 1 minus the probability of no yellows, which is BBB. And the probability of BBB is, we already said, that's going along this branch here. So it's 5/11 times 4/10 times 3/9. It's multiplying those three probabilities together. So 1 minus that. Oops. Okay, and that is going to equal, put in your calculator, and that equals 31/33. Alright, HSC question. Alright, there are 12 chocolates in a box. 4 of the chocolates have mint centres, 4 have caramel centres, and 4 have strawberry centres. Ali randomly selects 2 chocolates and eats them. Find the probability that the 2 chocolates have mint centres, same centre, different centres. Okay, so our 3 choices are mint, caramel, and strawberry. And she is choosing 2 of them. So on our tree diagram, we're going to have mint, caramel, strawberry. And that's the first choice. And then she makes a second choice. Mint, caramel, or strawberry. Mint, caramel, strawberry. Okay, so this is how we draw our tree diagrams. Now we just need to mark in our probabilities on each of the branches. Okay, so initially we got 4 mint, 4 caramel, 4 strawberry. So each of the probabilities is going to be 4 out of 12. We could simplify them to 1/3 if we want, but if we keep them as 4/12, it might be easier to work out the probabilities on the next branches. Because remember, it's going to be the denominator is going to be going down by 1. So we've chosen a chocolate, which means that out of the 12, there's only going to be 11 left to choose from. So our denominator on all these branches is going to be 11 for the second choice of chocolate. Kind of running out of room. Draw your tree diagram as big as possible is my advice. Draw it whole page. Okay, if the first chocolate chosen is mint, there was originally 4. In the first one's mint. That means there's only going to be 3 mints left to choose from on the second choice. But you'll still have the 4 caramel and the 4 strawberry. If your first choice of chocolate was caramel, then there's only going to be 3 caramels left for the second choice. There will still be the 4 mint and the 4 strawberry. And let's just check. 4 plus 3 plus 4, does that up to 11? Yes, it does. Or 11/11, which is 1 whole. If the first choice of chocolate was strawberry, that means there's only going to be 3 strawberries left, but you'll still have 4 caramel and 4 mint. Alright, let's do our sample space. Mint, 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 caramel, mint, strawberry. Caramel, mint, caramel, 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 strawberry. Strawberry, mint, strawberry, caramel, strawberry, strawberry. Alright, now let's answer the questions. Hang on, let me make this a bit smaller. Okay, made it smaller and shuffle it to the side. Let's answer the questions now. What is the probability that the 2 chocolates have mint centres? So that's going to be this one, mint, mint. So going along the branches, we're going to multiply 4/12. Whoops, 4/12 by 3/11. Didn't mean to cross that out. I thought it was on the other tool. 4/12 times 3/11. And putting that into your calculator, you get 1/11. Is the probability of choosing 2 chocolates that have mint centres. Part 2. Find the probability that the 2 chocolates have the same centre. So that means mint, mint, caramel, caramel, or strawberry, strawberry. So we've already got the probability of mint, mint. That's 1 in 11. Plus, because we're going between branches, the probability of caramel, caramel. Going along those branches in the middle there. Caramel, caramel. 4/12 times 3/11. Oh, looks like it's the same numbers there. And we've got strawberry, 4/12 times 3/11. Same fractions there. So really, what we could do, is because we've got the same thing 3 times, might even be easier just to do the 1 times by 3. So that's going to be 3/11. So that is the same as doing the caramel, which was, sorry, mint was the first one, remember? And then we got a plus caramel. And then we got a plus strawberry. So can you see, might be easier to see there. We've got the same fractions. So each one of those fractions is 1/11 plus 1/11 plus 1/11, which is 3/11. Okay, so a couple of different ways of working out these questions, whichever you find easier to work with. Part 3. What is the probability that the 2 chocolates have different centres? Alright, so different centres is that one. Hang on, is that the complementary event to the same centres? I think it is. So the probability of different centres is going to be 1 minus the probability of the same centres, which we worked out in part 2. So 1 minus 3/11, rather than multiplying along that branch, multiplying along that branch, multiplying along that branch, that branch, and then adding them all together. Can you see how using complementary events is sometimes a lot quicker? So 11 minus 3 is 8. 11. So we've got 8/11. And I'm going to leave to solve, not related to probability, but nevertheless still kind of cool. I want you to find an expression for the volume of this pizza if the radius, what colour can I use for radius that will stand out? Maybe green. You see that radius there? The radius of that pizza, we're going to say, is Z. And we are going to say the depth or the height of this pizza is A. Can you please find an expression for me for the volume of this pizza? And we'll talk about that in class next. Thanks. Bye.